Overbooking. So the second example that we will consider in revenue management will be overbooking. And the reason for considering overbooking is that we do have a lot of problems with cancellations or no-shows, right? So a large percentage of reservations for hotels, for air flights are canceled or right at some point in time. And also sometimes there are no penalties for those cancellations. And then the other problem is, of course, that sometimes customers even don't show up, even though they didn't cancel. And so the problem is we may fail to fill capacity if passenger cancels at the very last minute or doesn't show up. So the solution for this is, of course, to sell more units of capacity. That is overbooking. Before I go on with this, is that notice that even if the customer paid and doesn't show up, we shouldn't be happy that we now have an empty seat, because an empty seat, even if it was paid for, is still an opportunity to get another revenue and another profit contribution, right? So even if all the seats in a plane are paid for, if 5 of them are empty because customers did not show up for some reason, these are still a lost opportunity to increase our revenue and increase our profit. So don't think that no shows are not a problem. They are still a problem. They're actually the same problem as cancellations. In both of them, we have empty seats that mean an opportunity, lost opportunity to make more profit. So overbooking, of course, has a danger. The danger is that if we sell more than the capacity, some customers might actually have to be denied service, right? So if I have 100 seats, but I sell 105 tickets, what if those customers all show up, or most of them, right, more than the capacity, right, more than 100 in my example, will show up. I will have to deny service to some of them, and that means, they may be dissatisfied and I might have additional costs. We will again consider an example of a hotel which has 118 rooms, right? And then we will just consider the low fare, assuming that we're just selling all the rooms for $159. And we will assume that there is a probability for no-shows. So basically, we will assume the number of no-shows, right, is X, has a Poisson distribution with mean mu 8.5. So notice that we actually don't have a distribution here for demand. We have the distribution here for lack of demand, right, for no-shows. This is a bit awkward and it might confuse you at some point, but if you're careful, you should be able to understand the logic here. So now, cost of denying a room to customer with confirmed reservation is $350 in ill will and some penalties. So, for example, if a customer comes to the hotel and we say, sorry, we realize you have a reservation, but we don't have a room. However, we can offer you a room in a nearby hotel and a voucher for free dinner or something else, right? Or for another free night or something. We estimate the cost for this situation to be $350. So the question now is how many rooms, which will be denoted by Y, should be overbooked, sold in excess of capacity. So again, it's a single overbooking decision before the number of no-shows is realized. And this number of no-shows, X, is uncertain and has a certain distribution. So notice that this Y is the quantity Q, just a different symbol used here, and X is demand D. So we have a case of underage, right? If we have insufficient number of rooms overbooked, so the number of no-shows exceeds the numbers we overbooked, we have empty rooms, right? And so underage cost, the quantity that we overbooked is too small. We have empty rooms, and those rooms could have been sold for the low fare $159, right? So we could have sold an additional number of rooms for the low fare. What if we overbooked too many? So that means the number of shows is small, too small, smaller than Y, and that means we actually have too many customers showing up and we have to pay the penalty. So the overage cost, right, we overbooked too many, is for each room that we overbooked is $350, which is this penalty, right, that we introduced here, 350, right? So if you understand that this is the case, now we are ready to use the news vendor model. We can calculate the critical ratio as before, underage, cost of underage divided by the sum of underage and overage costs. It is, again, by chance, as in the overbooking example, it is close to 0.33125. So if the mean demand for no-shows in this case, mean number of no-shows is 8.5, with this critical ratio, which is less than 0.5, we should select a quantity that is somewhere less than the mean. And indeed, if you use the news vendor model, the one with Poisson distribution, you'll get quantity y equal to 7. So that means we should overbook by 7 rooms. So we should allow reservations for whatever capacity, for example, the 118 rooms plus 7, y is 7. So we should sell or reservations, right? Make reservations for 125 rooms when in fact we have 118. So several measures we can now calculate based on the news vendor model logic. First, what is the probability that we'll be turning down customers who have reservations? Well, we will be turning them down if the number of no-shows is smaller than by how much we overbooked. So if we overbooked, if you recall, 7, if the number of no-shows is 6 or less, we will be in trouble, right? So this is when the number of shows is 6 y minus 1 or less. And this is, of course, cumulative distribution function for our demand, which is Poisson, at value y minus 1 or at value 6, 7 minus 1. And of course, you can calculate this in Excel using Poisson function, providing it a value 6. The mean for our Poisson distribution was mu 8.5, and this is just indicating that we want a cumulative value for this distribution function. So 25.6% will be the probability. The next measure is what is the expected number of rooms that will be empty? Well, to see how to calculate this is to we have to realize that rooms will be empty when x is higher, right? We need x higher than y. So we need the demand to exceed the quantity, right? And so that is in the news vendor model. This is what we call when we have this, we have some lost sales, right? But in this case, this will mean that there are empty rooms because the number of no-shows, for example, was 8 when we overbooked by 7. We have 1 empty room, right? But in the news vendor terminology, this is lost sale. So that's why we can use the expected lost sales from the news vendor model and find out that the number of empty rooms is expected to be 2.02. Remember, fractional value is fine because that's an expectation. That's an average over many possible integer values. What is the expected number of penalties? Well, that will be the news vendor's expected leftover, and that's going to be 0.52. So we expect to pay on average half of the penalty for the night, right? How much is expected revenue? Again, here the formula is different than in the news vendor model because we have special circumstances here, right? Expected revenue, we will sell. Remember, the assumption is demand is abundant, right, for this low fare. So we can sell capacity plus what we overbooked, right? So we can sell 118 plus 7 for $159. But if we have expected leftover news vendor, which is the expected number of penalties that we will pay, right? We have to subtract those expected penalties that we will pay, 350 times the number of those penalties, an expectation that we have to pay. So that's 350 times 0.52. So our expected revenue is 19,693. And of course, if you again assume that without revenue management, without overbooking in this case, we would get only 118 rooms sold at the price 159. The base case is $18,762. That means overbooking allows us to increase revenue, expected revenue, by 5%. And the final note here is that booking limits, protection levels that we used before, right, on the same example, can be used together with overbooking for the lower fare, right? We can use it together with overbooking for the lower fare. It's basically that when we use booking limits, we come up with a booking limit for the low fare, and now we can use this booking limit for the low fare as a capacity of overbooking. I mean, capacity in overbooking.